This video is going to focus on Taylor expansion and finding the equation of a tangent line at any given point on a polynomial equation. So let's look at problem 1, where we are given the polynomial equation f of x equals 7x cubed plus 2x squared plus 6x plus 1. The first part of A tells us to Taylor expand the given equation at x is equal to 2. Now in order to do that, we have to divide this by x minus 2. Because to find what you're going to divide by, you move everything to one side and make the equation equal 0. So over here, we'd subtract 2 from both sides, which would give us x minus 2 is equal to 0. So because of that, for part A, we're going to take 7x cubed plus 2x squared plus 6x plus 1 and divided by x minus 2. So the first step to this problem would be to find out how many times x goes into 7x cubed, because you would divide the value we get by x minus 2 and subtract that from this whole equation. So we know that 7x squared times x would make 7x cubed. So therefore, the first value up here is 7x squared. So 7x squared times x minus 2 would give you 7x cubed minus 14x squared, and we would subtract that. So 7x cubed minus 14x squared. After we have this done, we distribute the negative, so it becomes 7x cubed minus 7x cubed, which is 0, so we ignore this value, and this would become 2x squared plus 14x squared, which would become 16x squared. After we do that once, we bring these two values down and do the same thing we just did again. And we do this over and over until we are left with a value we are not able to simplify anymore. So let's go through this whole process of division together. The next step would be to find out how many times x goes into 16x squared, which is simply 16x. So you would add 16x up here and multiply 16x to x minus 2. Therefore, we get 16x squared minus 32x. And once again subtract after distributing the negative. So this would be 0, which we ignore once again. And this would be 32 plus 6, which is 38x. And we bring the 1 down. So we are left with 38x plus 1. Then we do the same process one more time, and of course, 38 times x is 38x, so we add 38 up there, and then subtract 38x minus 76. Which gives us, keep in mind this is 38, once you distribute the negative, this is 0, so we ignore it once again, and this is 77. So, after expanding this one time, instead of having this big equation, we are given x minus 2 times 7x squared plus 16x plus 38, all plus 77. But if you look at this, you can see that this is not expanded or simplified all the way, because this can be expanded even further. So let us try our best. Let us do that now. Alright, so what we had was 7x squared plus 16x plus 38. And once again, we divide that all by x minus 2. So we do the same thing we just did, where we figure out how many times x goes into 7x squared, which is 7x times. So we subtract 7x squared minus 14x, which once you distribute the negative, this is 0, so ignore it, and this would be 16 plus 14, which is simply 30x, and we bring this down, so it's plus 38. Then we know it goes in, x goes into 30x 30 times, so plus 30, which gives you minus 30x minus 60, which once you subtract, this gives you 0, so ignore, and this gives you 98. So for this expansion or simplification, in the end, we are left with x minus 2 times 7x plus 30 plus 98. And as you can see, 7x plus 30 cannot be simplified anymore. And so we rewrite our simplification to make it as simple as possible. So originally, we had gotten x minus 2 times 7x squared plus 10x plus 38, all plus 77. But after we expanded it once more, we now have x minus 2 is equal to x, or times x minus 2, 7x plus 30 plus 98, all plus 77. Because this expansion we got was an expansion of this. So we just plug in the simpler version of this where this used to be. So after you do this, it's really simple because all you do is distribute this to here and to here. So you get x minus 2 squared times 7x plus 30 plus 98 x minus 2 plus 77. Once you're here, this part just copies down, and this part simplifies further into 98x minus 119. So that's that part right here. So we are left with this plus this. And that is the simplest. That is how you Taylor expand the polynomial that was given. Part 2 of the problem, or part B of the problem, tells us to find the slope and equation of the tangent line, given the polynomial is at the same point it was at before. Well, that becomes really easy for us, because to find the equation of a tangent line of any polynomial, what you have to do is Taylor expand it, which we already did. And the Taylor expansion gave us this value. So when you're looking at this and trying to find the tangent line and the slope, you cross out this beginning part and you look at the part that's left back here. And looking at it makes it very clear that the slope of the tangent line would be 98, and the equation would be y is equal to 98x minus 119.